My name is Greg George, and this is a basic wrap cleanup tutorial. So you see here that I have wrap open up on my screen, and I'm just going to drag in a part. If I drag over here on the model manager side, it'll import it to the existing file. If I drag it into the graphics area, it will open that file. So what I mean by that is if I drag it here, you'll see that it'll open a file. Now if I drag that same exact file over here, you'll see it'll add the file twice to this file here. And then if I go ahead and drag it back to the graphics window, you'll see that it just opens that file. So that's an important distinction. You'll notice right on the left-hand side that we have two different groups of scans here. So if I click back and forth, you can see that the green means that it's currently selected, and these are point clouds. If I want to just show only one of these groups, I can right-click on it and say I want to hide something. I can hide one of them. Or another thing is you can use the F2 shortcut. So F2 will show only the object that you have selected on screen. So if I hit F2, you'll see that it shows only, show only there. Now, inside of the folder, it works the same way. If I select individual scans, and I hit F2, it'll show only that individual scan. To zoom and rotate, you use the middle mouse wheel to rotate, and then you scroll to zoom, and it zooms on mouse. So you see here, if I zoom over that piece, it'll zoom into that. If I zoom in there. Now, if I hold Alt and click the middle mouse wheel, that will allow me to pan. If I click outside of the object, you'll see I can rotate around. If I click inside of the object, it will dynamically rotate around that point that I clicked inside of the object. But if I click outside of the object on screen, you'll see it'll use the center of the object to rotate around. Now you can change all that if you want to turn off the toggle dynamic rotation center. You can actually set the rotation center in this menu, but the dynamic works really well as long as you know what it's doing. So if I click right here, you'll see that it rotates about that spot. And not only that, with zooming in and out, you can get away from panning and all that stuff. So those are some of the basic interface things. You do have this tool down here. If you want to click on the widget, you can use that for your views. Also, with the widget, you do have these arrows to rotate around. And down below, you do have this. It will tell you what's possible with whatever tool you have selected or whatever you're running. So if you actually go inside of a tool, you can see what options are available. All right, so those are some of the basic interface. Oh, on the right-hand side, you see you have some selection tools, and we'll cover those here in a second. And a display tab here is important to know. So if you toggle over to the display tab, you can turn things on and off. So because this is a point cloud and this is ordered data, I can turn on the actual points for that ordered data. And if I just show that, ordered data is basically a grid of points, and we connect them together into these cells. And it makes the data lightweight. It automatically does some overlap reduction and things like that. You can scan as ordered data or raw data in here. Ordered data just saves a lot of processing time if you use that type of information. So here are my scans. Let's go ahead and clean them up and align them together and merge them. So you can see here that we captured a little bit of the table, the clamp that held this part. So what I like to do is just look at it from this perspective here. And by default, I have this lasso selection tool here. So I can select that data, but you notice it doesn't select all the way through. So you do have the option to select visible or select all the way through. And select through will get everything there. Now, one thing about selection tools that's a little different in here is you notice that the green side is the outside and the yellow side is the inside, the back faces. So you also have the ability to turn on back faces, turn on and off back faces. So what I mean by that, if you say visible and I turn back faces off, you'll see it will only let you select the outside. It will ignore the yellow side. And that can be really handy for cleanup. But if you turn on select through and back faces off, it'll select through and only select the green sided faces that are facing you all the way through the object. Now, if you want to get everything like we were doing before, I can just turn on select through and back faces mode. Other selection tools we'll get to as we go along here. So I'm just going to hit F2 on that group. And you see I still have a selection going here. If I want to right click and hit clear all, I can clear that selection. Or I can hit Control C and that will clear the selection. So if I select through, back faces on, I can just window in and delete all of that information there. Now I have everything cleaned up. So I'll look at it from this perspective. And I like to use the straight side of the lasso. So you can see that, you can delete that. Now, if you do see some things inside of the scan data where there is some chatter or some things that you want to manually edit here, like right here, there's a little bit of streaking going on. Another trick here that's really handy is the ability to hold Shift and Control and click on a scan data set. And if I click on that scan data set, and I just keep clicking around until I get the one that I want, and then hit F2, I can show just that one. And then that'll allow me, if there's a piece of data that I don't want, and I want to crop it out. So here's another one. There's a little bit of streaking that goes on there. So if I come in, select that and delete it, click back on the group. So it makes it real easy if you notice something. A lot of these artifacts I don't have to fix. I'm just showing you some of the tricks that are available here. Delete that, go back to group. So the data looks fine on this one. And I'll hit F2 and see this one here too. And again, just to exercise that tool again, if I hold Shift and Control F2, and sometimes it jumps out like that too, so it can be a little bit disorienting, I guess. So if I want to select that and delete it, but if I zoom out a little bit when I click on it, right there, that's the one I want. You can hit F2, and you'll see that that's a little streaky right there. Okay, so now that I have two scan data sets, I want to go ahead and align them together. So if I come over to Alignment and Manual Registration, oops, I need to select both objects that I want to align. So I select both of them by holding Shift and go to Manual Registration. There are two different types of registration. One is single point, which single point is going to use just the orientation of the part and the point that you click to try to align the two objects together. And an endpoint allows you to click any number of points that you want to align the two objects together. So I'll show both of those real quick. The first thing you define is which group that you want to be fixed, which group you want to be floating. And just as a general rule, I like to go ahead and just align those two objects in the graphics window. And then for the single point, it actually is using that alignment in the graphics window to help guide it. So if I align them in the graphics window and then hit a common point between the two, down below you will see that it's going to work its magic and piece those two together. So for parts that have a lot of overlap between the two different scans, this works very well. But there are some times where that that's not enough because you barely have enough data. So if I just hit unregister and put them back, the other method is endpoint. So endpoint, I'll go ahead and reorient these two parts. We'll take the number of points that you click. So if I just click this one, I'm just clicking common points between the two scans. And you'll see as soon as I get 3, it's got enough to start updating the alignment. And if I just keep adding, it will keep calculating based on adding those points. And as I add them, they can either get better or worse. That actually looks very good whenever the data bisects itself over and over again like that. That's a good sign. Now down below, by default, the software will add these to the group. So basically it'll take both folders and merge them together. I like to turn this off, hit next and OK. So I align them together, but they're still separate groups. And the reason why I'd like to do that is I like to run a global registration, which is going to take both of those groups and best fit them together based on their overlapping geometry with a tighter tolerance. So it does a pretty good job. Now, once I do a global registration and get a tighter alignment between the two, I like to break them apart and group them back together. So now all of those individual scans are in one folder, and then I run global registration again. So before, only the two groups were allowed to move around between each other and align. Now that I group them all in one folder and I run it all together, now every scan is allowed to move, and the software is going to move them and shuffle them around to get the most ideal alignment between the objects. So you see it's calculating there. Now that it's complete, again, having a lot of bisection of the data is good. That's showing that it's very accurate. Now that I have all these scans in one group, you can see I can still come back and edit some stuff. So if I see a little artifact sticking out, Shift Control F2, window in, delete, go back, F2. So I like to just give it a once over and make sure there's nothing crazy like that sticking out like this right here. Again, not all of those have to be fixed. It'll get averaged out many times when it's merging. It'll go ahead and remove outliers and things. Some of these I can get without having to show only that one scan. Like this one. When I scanned this, I didn't really calibrate or anything. I just left it as is. So there's a little bit of deviation and streaking going on. And it's good because it gives me something to show, like a more of a worst case scenario. All right, so I'll look it over. Again, it's not necessary to really fix all of those. And then now it's time to go merge. So if I come over to the points tab and I merge these together, what this is going to do is take all the point clouds and create one polygon from it. Now, a popular mistake is to select wrap. Wrap will take each individual cloud and make it a polygon object. And that's usually not what you want to do. What you want to do is merge them together. So in merge, it actually has a bunch of different things that it's doing. It's going to do local noise reduction on each individual scan pass. It will do another global registration, unless I turn this off. This tells me to keep original data, just in case. Delete small components, little floating pieces out in space. And then the final step is max triangles. What this will do is decimate that data down below this number here. So this is a pretty lightweight object to begin with. So this probably won't even come into an effect. But 1.5 million triangles is a nice small file size. Now there's some other options in here that I like to turn on. Remove overlap between the scans. Optimize for sparse data, so it gives it more freedom to connect sparse data together into the polygon, and then optimizing for evenly spaced data. So I actually turn those all on and then hit apply. So you see down on the right hand side, it's calculating, and you can see that it's doing the alignment phase right now, and then it'll walk through each step. All right, now that it's done, you'll see that my polygon object is blue. So we color the point clouds, the ordered point clouds there, that green and yellow for the front and back faces. Now for polygons, the front is blue and the back is gold or yellow, and then the boundaries to highlight those are green, so you can see them. Now some cleanup tools, just to show how the polygon cleanup tools, this same concept works exactly the same inside of the polygons, except for now we're going to do some hole filling. So you see there's a little missing data there. If I click on fill single, I can click on the boundary and it will fill it. Now we have a bunch of different algorithms here: curvature based fill, tangent fill, flat fill. They all have their use cases. By default, I like to keep it on tangent. It does a pretty good job. And then I will progress to the others depending on what my application dictates. So in that case, I just went ahead and used tangent. Now, if it's a large flat area, like this right here, if I right click, I can delete triangles. I'll go ahead and delete some so you can see. So I deleted a hole all the way through. A flat area, flat works really nice, but tangent you'll see will still fill. So if it's really, really flat, like all the way across the bottom of a part, a lot of times I'll use flat. But if it's an area like this, I'll just stay on tangent. Now, if I want to fill a partial or bridge, these are the different methods. So I've been doing fill complete so far, where I just click on the entire boundary and it fills. But you do have the ability to do a fill partial, which I can click a point, another point, and select which half I want to fill. And then you also have bridge. Bridge likes you to click and drag, and it will make a bridge across. So you can see here, there. And as I showed before, there is a right-click hidden menu here that you can use. So I can toggle over to editing triangles, editing boundaries, deforming regions and stuff, but I don't have to do that. I can always toggle off the hole fill tool and do that stuff, and then go right back into hole fill if I want to. So let's go fill that one. Now, if I hit the Z direction, you'll notice this thing's floating out in space, Y direction. So I want to align this part. So you see here's the coordinate system. There's where 0 is. I want to align this to that coordinate system. To do so, I'm going to fit a couple planes to this and then square those to the coordinate system. So as you can see, the bottom is not flat whatsoever, and even the sides are bowed. So I can use some different features on this part to put the coordinate system wherever I want to. So if I want to put the coordinate system on this corner here, we can do that, or at the center of that sphere. It just depends on what you want to do. So I'm going to go ahead for this one and just use like the slot just to keep it simple. So if I want to select triangles, I can just window in and select them this way. Or if I clear that, we do have a select by angle mode, which sometimes I have select through on. You'll see here. If I turn through off and click that, it will select large flat areas very easily. That's what this tool does here, select by angle. And I can come over to features and fit a planar feature using the best fit tool. Or I can use the shortcut in the right-click menu, which will allow me to hit apply and fit a plane to that region. And the way this tool works is you hit next and OK, and it will accept that plane. So that plane is now sitting on top of this polygon object. So if I want to do that same thing for this region right here, and you can stay in that tool, you don't have to get out of it. I just have a habit of getting out of it. But and if you want to deselect from an area, you can use Control. You don't have to hold Shift to add to a selection. By default, it saves the selection as you go. So now that I have those three planes, I can use those for my alignment. If I come over to the Align section, Align to World, and the way this works is you're going to match either these planes or axes or points up with the origin construction entities. So these are the planes that I created, and then these are the X, XY, XZ, YZ planes, and then here are the direction vectors, and then the origin point. So just to keep it simple, I can say XY and that plane. You can see that it highlights that plane. You're going to tell it to match those two together. So you see down below, it's going to match those two. Now that only matches that single plane. So if I say that I want the XZ and the YZ to be plane 3. So now you see I have all three. If you zoom in, you can see that it puts that coordinate system on that plane, on this plane, and then on that one. Now if you want to change the order, you can bump the order up and down through here. If you want to flip-flop, I could take that, for example, the first plane, if I want to flip-flop the direction that those two match, you'll see that it'll flip the Z. So if you're happy with that coordinate system position, you can hit OK. Now you see that the coordinate system is at the corner there. So if I hit the Z, it's squared up to just that slot in that area. So that's the process of taking raw scan data and processing them into a mesh and aligning them to the world.